Hello friends, uh, today's lecture is on merchant circle diagram, and this is the second video on merchant circle diagram. Hopefully you last video was useful for you and you watched that video, and if it is useful for you, then please like, share and subscribe this channel. And now in this video I will discuss how to draw the merchant circle diagram. If in especially in the BTech courses, if sometimes it is asked in the subject to draw the merchant circle diagram, or in any competitive exam some of the use or any question numerical will be given about the merchant circle diagram, then you can easily solve using if you are watching this video. So I will explain how to draw in a very easy way. So first of all, I will draw here a simple diagram of the cutting. Like I will draw here. First of all, I will use some of the forces which are used during the cutting operation, and I will use those forces to draw the merchant circle diagram. So one of the force is the FC, that is cutting force. Cutting force. Second one is FT, that is thrust force. Thrust force. This is FC, cutting force, is the horizontal force. FT is the vertical force. Then F is the friction force. Friction force. Cutting force and thrust force will be perpendicular to each other. Then friction force and normal force. N is the normal force. That is the normal to friction force. Normal force. These are perpendicular to each other. Then Fs. This is the shear force. This force will be along the shear plane. And the force perpendicular to shear force is the Fn. This is the normal to shear force. Normal to shear force. These both are perpendicular to each other. So I will use these forces to calculate to draw the merchant circle diagram. First I will draw here a simple cutting diagram. This is the workpiece. Suppose this is the tool, cutting tool, and this is the chip flowing with velocity v, chip, and this is the tool, and this is the workpiece. So as we know, chip is flowing at the rake surface. This is the rake surface of the tool. Chip is flowing at this surface. So there will be some friction between chip and tool. So chip is flowing in this direction, so friction will be in downward direction. So this is the friction force. Let's assume this is the friction force F. And as due to mechanics, as we know in the mechanics, there will be always a perpendicular force. This is the normal to the friction force N. And due to this force F and N, there will be resultant R. This is the resultant force R. Let's R. So this R resultant force can be resolved into two components, that is for friction force and normal to friction force F and N. Next, we have if this R resultant force is acting on this chip due to tool, then there will definitely will be a equal and opposite force, that is R dash. That will work, that is working in this direction, R dash. Let's R and R dash are equal and opposite. Okay, and this R dash can be resolved in two components. That one is friction force. This component will be in direction of this shear plane. Shear force. That will be in the direction of shear plane. Fs, friction force. And one component will be this is friction force and normal to friction force are at 90 degree. Similarly, friction force and 90 degree, this component will be at 90 degree of this, at 90 degree. This is at 90 degree. This is Fs and this is Fn. We can say simply Fn. Let's assume Fn. This is the normal to the this shear force. So next is the there is a major force that is responsible for the cutting operation, that is called cutting force, Fc. This is the major force responsible for the cutting force, and so this will be in the direction of the horizontal direction, Fc, cutting force. And there is a opposite force at 90 degree to this, that is called Ft, thrust force. These two forces are at 90 degree, and this is the rake surface. So this rake surface is making an angle with vertical alpha. Alpha is the rake angle, as I have discussed in the last lecture also. So now, how to use these forces to draw the Merchant circle diagram. Now I will tell how to I will discuss how to draw the Merchant circle diagram. In Merchant circle diagram, in question, first of all, we have some background data. We should have some background data, like during cutting we can measure some of the forces, like cutting forces or thrust forces we can measure using dynamometer. As you know, dynamometer is an equipment or a tool that is used to measure the forces during cutting. So we can use dynamometer to calculate the cutting force or thrust force. So we should have some of the values, like alpha rake angle. We can measure alpha rake angle during the cutting. So using these values, we will draw the Merchant circle diagram, and we will assume some scale, like to draw this diagram we will assume scale, like suppose 200 Newton is equal to 1 centimeter. This is the scale. This is the y-axis, this is the x-axis. Suppose this is our cutting tool. This is the cutting tool which is making an angle alpha with this vertical line tool. So let's by dynamometer we have measured the force, and its value is equal to let's suppose 1000 Newton. That is equal to, according to this scale, that will be equal to 5 centimeter. This is the value of Fc, cutting force. So at x-axis, let's suppose this this is 5 centimeter Fc. So this will give the value of Fc, 5 centimeter. Then as we know, Ft will be at 90 degree of this cutting force. We have calculated the value of Ft, and this is suppose 800 Newton. So this will be equal to 4 centimeter, or suppose this is 400 Newton. 400 Newton. So this will be equal to 2 centimeter. So let's move this in this direction 2 centimeter, and this will give the value of Ft. Now by extending a line from this point to this point, this will give the resultant. This will give the resultant R. So in Merchant circle diagram, this is like this question can be asked in competitive exam, that what is the diameter of the Merchant circle. So always we take this resultant as, we consider this resultant as a diameter of the circle. Let's assume this is the diameter of circle and draw a circle. Suppose this is the circle. So this is the diameter of that circle. Resultant is R equal to diameter, equal to resultant. Okay. So now as we know the value of alpha, let's extend this line. Extend this line in this direction and stop at this point where this will meet at the circle. So measure this length from this point to this point. What is this? This is the friction force. Suppose this is equal to 4 centimeter, then the value of friction force will be 800 Newton according to this scale. Now draw a line from this point to this point. What value? What this will give? This will give the value of N, that is normal to friction force. Now measure this length, and this will be the value of normal force. The angle between this resultant and this normal force will be the friction angle. Let's beta. Beta is the friction angle. Friction angle. We will use this beta to calculate the coefficient of friction. Now there are two forces still we have to measure, that is Fs and Fn, shear force and normal to shear force. So now we have to draw the line of shear force, we have to calculate the shear angle, that is phi. How we can measure this? If we know the value of alpha, rectangle, and we know the value of R, that is thickness ratio T1 by T2, then we can calculate tan phi equal to R cos alpha divided by 1 minus R sin alpha. So this will give the value of phi. From here we will calculate the value of phi, and suppose this is like 10 degree or 20 degree, whatsoever, this at this angle phi, we will draw a line, and the point where it meet the circle, we will measure the length. This length will be equal to shear force, and from this point to this point, this will be the normal to the shear force, that is Fn. So we can see here that this is also a 90 degree. The point that exists at the periphery of this circle, this of where the two forces are meeting, this is the 90 degree angle. Okay. So now we have all the forces, 6 forces, and we have angle phi, and we have this angle, this is alpha, so this will also be equal and opposite angle, this will also be alpha, this is beta. Now we can use how to calculate the value of resultant R. There are 3 triangles, this one and this one and this one. So anyone we can use, and we can draw the we can calculate the value of R, resultant R. Using Pythagoras theorem, we can calculate the value of R. So suppose I am using this triangle FC, FT and resultant R. FC, FT cutting force and resultant R. R equal to FC square plus FT square. We can also calculate by using this equation, or we can directly measure from here. Okay. And how to calculate the friction angle? Mu is equal to the coefficient of friction. Mu is coefficient of friction. So this is equal to tan beta. Beta is friction angle, and from this this triangle, this tan beta equal to F by N. F by N. So we can calculate the virtual coefficient of friction using this Merchant circle diagram. Now we can calculate the power consumption. We can calculate the power consumption. as we are using calculating forces to calculate the power consumption or energy consumption, that is the purpose of to draw the merchant circle diagram, or using these all the theories. So how to calculate the power consumption, especially the major force is involved in cutting, that is FC, cutting force. So this is also called cutting power consumption or energy consumption. Energy consumption. So this will be equal to FC into VC. VC is the cutting velocity, FC is the cutting force. So this will give us the power consumption or energy consumption. Similarly, we can calculate the specific power consumption, that is the cutting power consumption divided by volume or material removal rate. And next is there are some theories that is generally asked in the competitive exams. So I will discuss about those theories, and I will tell the way how to remember them. One is the merchant theory. Merchant theory. Mostly in all the theories there will be three angles will be used. These all: alpha, beta and phi. Okay, and we will use pi by 4 on the right hand side. So let's suppose in first case there will be phi plus beta by 2 minus alpha by 2 equal to pi by 4. So in most of the theories pi by 4 will be on the right hand side, and the term come with alpha will be with negative sign, and the term with phi and beta will be with positive sign. In first case we will use beta by 2 alpha by 2 equal to pi by 4. In second case, second is the Stabler theory. Stabler theory. In this case we will not use the beta by 2 only, we will use the beta only. Phi plus beta minus alpha by 2. This is the way to remember this theory formula. And next is the Lee-Schaeffer theory. Lee-Schaeffer theory. Now this is the phi plus beta minus alpha equal to pi by 4. In first beta by 2 and alpha by 2, in second only with alpha by 2, and in third there is only single phi plus beta minus alpha, not the term not with the divide by 2. And next is the modified merchant theory. This is very important. Modified merchant theory. This will give us the merchant constant, Cm. Cm is the merchant constant. So Cm equal to 2 phi plus beta minus alpha. This is very important. Remember this. One more formula is here. I want that you should keep in your mind. That is very important. This angle is alpha, rake angle, and this is the 90 degree. So let's assume this is theta. This angle is theta. Let's suppose this is theta or x or anything. So what is the value of this angle? What is the value of this angle? This will be as from this triangle. This angle is this is 90, this is beta, so this will be 90 minus beta. So this total angle is 90, that is equal to theta plus 90 minus beta plus alpha. So this will 90 cancel each other, and this will be beta equal to theta plus alpha. This is important. This beta will be equal to this angle plus this angle, theta plus alpha. Remember this. Sometimes this will be used in the numericals. Now we will calculate the shear area. Now first of all, I will demonstrate you what is the shear area. Suppose this is the workpiece. Extend this in 3D. So this area is the shear area. This one. This is the shear area. This is the, as you know, this is the shear plane, and the area along this plane will be the shear area. And how to calculate this area? This is the width B. Suppose width is B, and this width into this length will be the shear area. How to calculate this length? As you know, this is the T1, uncut chip thickness, and this angle is the phi. So what is the value of this? Suppose AB. This AB, this is equal to sine phi equal to T1 by AB. So AB equal to T1 by sine phi. So this length is T1 by sine phi into this length. This will give the shear area. Shear area equal to B into T1 by sine phi. And similarly, we can calculate shear stress force divided by this area. Shear force divided by this area will give the shear stress. So I think this is enough for this video, and still our merchant circle diagram topic is not completed yet. Remaining formulas and theories I will discuss in the next lecture, and I will discuss how to calculate various formulas that generally we have to remember for the competitive exam or to solve the numerical. How to easily remember using some of the practice. You can without remembering, you can find the way how to calculate these equations or formulas to solve problems related to the merchant circle diagram. So thank you very much.